Alright, so just to go over first principles of logarithms. Suppose you've been given y is equal to natural log of x. How do you basically differentiate that from first principles? What do you know about it? Okay, so basically, let's call our formula. Recalling our formula, we know that from first principles, the derivative is equal to the limit as h or delta is equal to approaches 0, and then we have f of x plus h minus f of x divided by our h. Okay, so we can just substitute right away. We know that we have a limit as h approaches 0, and then for x plus h, I've already explained on functions to say f of x plus h implies where there's x in the function, you plug in the x plus h. Okay, that's the implication. So we have the natural log of x plus h, and then that one just means xx. So where there's x, let there be x. So that's minus natural log of x as it is. This ought to be divided by h. Okay, so this is where it gets interesting now. So one thing that you have to take note of is the fact that we apply the logarithmic rules that you know. So are you able to picture any rule here? Okay, so think of addition or subtraction. So in this case it is subtraction. So when you've got the same log and base, you can actually, when you're subtracting, you can divide. So in this case x plus h over x. If we are adding, would have multiplied. So but in this case first principle is always a minus, so we're going to divide, and then over our h. Getting interesting, right? At this point we can divide by the x throughout. So x plus h can be divided by x throughout since it's a common denominator. For the first part you're going to have 1 and then plus h over x. So you have the limit as h approaches 0, and then you have natural log of 1 plus h over x. Okay, this is all being divided by h on the bottom. Okay, anything that you can actually picture at this point. So we can pull out this h, so that we have 1 over h, and then remain with the limit as h approaches 0 for the natural log of 1 plus h over x. Actually, even before we do that, okay, so this is equivalent to the limit as h approaches 0, 1 over the h, and then natural log of 1 plus h over x. Okay, we can clearly see that we've just pulled out this. We just try separating so that we create a kind of a logarithmic relationship. Okay, this is very intentional, and let's try to make up something here. So just a quick reminder, in case you've come out, you've come across some of the tricky limits. The limit as t approaches 0, in a case where you have 1 plus t raised to the same power 1 over t, this is equal to an exponent. Okay, so you want to write this down somewhere. So I want to come up with something that will come out that way. So of course in the brackets we want to have a t. So let our t be equal to h over x. Okay. And then also intentionally from the same expression, if you try to make h a subject, since we also have h somewhere there, if you make it the subject, it's going to be a product of t and x. So we can have, let's substitute the limit as h approaches 0, and then for 1 over h we're going to have 1 over tx, and then the natural log of 1 plus h over x is a t from what we've said there. Okay, now if you remember our limit identity, in the brackets we did have 1 plus t, okay, raised to the power 1 over t as a power. So let's come up with that. So you know that this can be split, right? That can be written as 1 over t multiplied by 1 over x. Alright, so let me rewrite that. 1 over t multiplied by 1 over x. And intentionally, this can become a power using the logarithmic rules that we know, or laws that we know. So that becomes the limit as h approaches 0, you remain with 1 over x here, and then the natural log of 1 plus t raised to the power 1 over t, which is now almost identical to the identity that we have introduced you to. I guess it's new to you. So at this point, let's pull out this. We have 1 over x, and then the limit as, now that we've dealt with it, at the point where we had substituted t, actually this whole thing should have changed to t approaching 0, because we don't have the h anymore. So take note of that. You should have remembered. So t, as t approaches 0, we have the natural log of 1 plus t raised to the power 1 over t. Okay, I'm sure you can now see the identity that we were talking about. Alright, so the identity is implied as t approaches 0. If you've got 1 plus t in the brackets raised to the power 1 over t, this gives you what? So this gives you e. So you have 1 over x and then multiplied by e. Okay, this is specifically supposed to be for this part. Okay, so natural log of this part, after substituting this 0, it gives you e. Okay, so the identity owes the limit as t approaches 0 for 1 plus t raised to the power 1 over t. That's equal to e. So that's without the natural log. So but the natural log still stands. So now the natural log and the exponential are inverses of each other. So that's basically just going to be equal to a 1. So 1 over x multiplied by 1, which is just basically 1 over x. And that's where the short form is the derivative of natural log of x is 1 over x. Okay, as simple as that looks. That's how you handle this question. Now feel free to pause the video and try out the case where you have y is equal to, instead of just natural log of x like the previous question, now let's say maybe it was like natural log of 2x. Pause the video and try out this one. Okay, so from first principles, just like we've done in the previous one, um, this is going to give you the same answer, which should be 1 over x. So if you've gotten a different answer, then you have to review your process. So basically, we know that even if we had to differentiate this by just basic rules of logarithmic differentiation, we understand that the derivative of a log is just the derivative of what's there. Derivative of 2x is 2 divided by 2x itself multiplied by the natural log of the base. The base in this case is e. So that gives you 2 over 2x, which is equal to 1 over x. So you should get the same answer. And basically, how does that come out? If you had to substitute, of course, in the same equation that we were looking at, you're going to have something like the natural log of so imagine you plug in there the x plus h, right? You'd have 2x plus h minus the natural log of 2x, right? And then all to be divided by h. This is the limit as h approaches 0. So if you group them, the natural log of 2x plus h and divided by 2x. So this is where you see that this and that will just actually cancel out. And at this point, we've gone back to the very first question that we were answering. Okay? So that's why the answer should be the same. I hope that makes sense. Now, let's make it more interesting. What about a case where you have, instead of it now being a coefficient of like the natural log of 2x, which is going to be like the same, what about if we say x to the power 2? How would you answer that one? So we do expect that the answer here should be derivative of 2x is 2x, the derivative of x to the power 2 is 2x, and then you maintain the x squared multiplied by the natural log of v, which you stand, that's going to be 2 over x. So pause the video and try out this from first principle. Let it give you 2 over x. Okay, so how do you go about it? So substituting in our equation the limit as h approaches 0, okay, and then we have f of x plus h is going to be the natural log of x plus h raised to the power 2 minus natural log of x squared divided by our h. So we just substitute in our function f of x plus h minus f of x. Okay, at this point we'll still go back to the rules of logarithms, right? So we're going to have the limit as h approaches 0, and then the 2 that we have as the power can become the coefficient from the rules, from the laws of logarithms. So 2 natural log of x plus h minus, maybe on the other side, 2 natural log of x over our h. Now we can do something interesting there. We can actually factorize the 2, right? So when you factorize out the 2, you're going to have 2, and then the brackets are going to have natural log of x plus h minus natural log of x. Okay, so you have 2, and then now you know that what you have in the brackets there, the same method can apply. So you have the natural log of x plus h now divided by x, right? And then over your h. So you see that everything actually can stand out because you can pull the 2 and everything remain as it was in the first question. So 2 the limit as h approaches 0, and then you end up with a natural log you can divide by x2 out there, you remain with 1 plus h over x divided by your h. You know what to do at this point, right? Let your t be equal to h over x. If you make h a subject, it becomes tx. So you end up with 2, the limit as h approaches 0. So at this point, actually, the moment you substitute, this is supposed to change to t approaching 0. Okay, so t approaching 0, and then natural log of 1 plus, so that would be t. For the h, we have tx. It's actually tx. So you have 2, the limit as t approaches 0, and then you can pull out that one to be 1 over tx, so that you just have the natural log as natural log of 1 plus t in brackets. Okay, now don't forget our identity, so we can pull out the one we can separate at this point. T approaches 0, so you're going to have 1 over t multiplied by 1 over x. Okay, now from the laws of logarithms, we know we can actually do some magic here, right? This can become the power of a log. Okay, so you have 1 over t as a power. So at this point, we can actually pull that one out since it's not having our t of interest. So we have 2 and then 1 over x, the limit as t approaches 0, and then we have natural log of 1 plus t raised to the power 1 over t. So we can see again that what we have can actually give us 2 1 over x. This with that, it's able to give us e, right? So we said the limit as t approaches 0, whenever you have 1 plus t raised to the power 1 over t, that's equal to e. So we're going to have the natural log of e, and then you know that's equal to 1, so you remain with 2 over x, which is the answer that you expect when you differentiate that logarithm directly. Okay, now let's add one more under the logs. Suppose they give you the natural log, in fact the log, let's say the log base of 10 x, that's your y. How do you differentiate that from first principles? Okay, so the same method does apply even here. Okay, so the limit as h approaches 0, and then the log that we're dealing with is log 10. So log of 10 x plus h minus log of 10, now just x. Same formula, f of x plus h minus f of x. That's where we've substituted, divided by h, right? How does this unfold? The limit as h approaches 0, and then you have log. So you can actually write lg as a shortcut. You can actually, even if you're dealing with base 10, even if you don't show a base, it's actually fine. So log of, in the brackets you can have x plus h divided by x. From the laws of logarithms, when you're subtracting bases or logs of the same bases, you can actually divide, okay, over your h. Now from what we've done so far, we know that if we are to get ourselves closer to our answer, we can divide by x, because that's the form that we actually want. So you're going to have the x divided into the x, it's a 1. So you're going to have like 1 plus h over x, right? That's what we have for that very first part when we divide by x for the numerator. And the denominator is to have our h there. At this point, this is where we now call upon our limit identity. So let our t be equal to h of x. We don't want the fraction in the brackets. So we have the limit as h approaches 0, and then we can actually pull out the h in advance, 1 over h, and then in the brackets we're going to have 1 plus t. Okay, now equally we can still make h a subject so that we have tx there. So the moment you just do that on your next step, the limit changes to t approaches 0, your h becomes tx. Okay, so I've already shown how you can separate the t and the x. You can have 1 over t, 1 over x. Okay, 1 plus t. So we can have the limit as t approaches 0, and then we can actually, let's start by pulling out the 1 over x, which is not part of the limit, and then we have the limit as t approaches 0, and then from the laws of logarithms again, 1 over t becomes the power there, and then over, we don't have anything on the denominator. Okay, so there's something that we've done, something very, very funny. If you've paid attention to what we've been doing, somehow along the way we omitted the log. So we're dealing with log 10, so there's a log there. So at that point you're supposed to have a log. Okay, so log, so we have 1 over x. Now our limit still stands. Our limit identity tells us this part with that part gives us e, right? So we're going to have 1 over x and then log of e from that identity. This with that part gives you e. Okay, now unlike the previous one where there were inverses, here we can just put a 1, so the answer can be 1 over x. Well, we've done the changing of bases, so I want to change the base to natural log. So 1 over x, changing the base would be, this is having a base over 10, so it's going to be the natural log of e to be divided by the natural log of a base that you're dealing with, 10. That's how we change bases. Okay, natural log of this divided by natural log of that. So you're going to have, on top you're going to just have a 1, because natural log of e is a 1, and then on the bottom you're going to have x natural log of 10. Okay, so that's basically what you end up with for this question, right? Yeah. So for your practice, feel free to pause the video and try to see what you can have if you add something like the natural log of log base of 10. What if we had 2x to 2 to the power x to the power 2? How would you handle it? Okay, so give me a comment in the comment section if you've managed to answer that one.